right, guys, let's take our seats, guys and gals. Take our seats and get started here. So, you're here for Hadoop and big data in introduction. So, before I get started, let's get a little feel of the audience. Like, who is a Hadoop user? Really? Excellent. Okay. Who is Hadoop curious? Okay. All right. And who's kind of like, I have no idea what this Hadoop thing is, but I'm here? Okay. Excellent. So who is, I would say, like a front-end web designer, so from the front-end side? Okay. What about like a back-end, so scripting, Java, that kind of stuff? Okay. Who is a analytics person? Okay. And maybe a database, DBA, SQL expert kind of. Okay. So we have a diverse audience. That's good. So one thing that you'll see, sorry about this, my keyboard is not working because I was using it at Valvoline and they spilled a carton of oil on my keyboard. So I need to get it replaced, but I haven't had time yet. So it's probably going to take me a couple tries to get the next slide. So a couple things. Number one, I actually don't have any business cards. Been meaning to get them. So if you want to contact me, I encourage you to do so. But you're going to need to take my email address and shoot me an email or give me a card. The other thing is I really, really encourage questions. This is your talk. You have a question, raise your hand or shout it out. Okay? I will stop and ask for questions if I'm not getting any, okay? And then I'm just going to sit there until you guys ask something, okay? So please ask questions at any time. Whatever direction this takes, that's fine. We don't have a whiteboard up here, unfortunately, because sometimes in the open-ended discussions, a whiteboard's pretty nice, but we'll do the best we can with that. So, about me. I graduated from the University of Minnesota, worked at Thomson Reuters or West Publishing in Eagan for about 7 years, and then about 2.5 years ago, I changed roles and moved out to, well, I didn't move out, I guess. I work for a company in California, but I still live here. And I started there as an instructor and then moved into a solutions architect, which is kind of a consultant, and now I'm in the engineering team. And so I'm a committer on 3 Apache projects. So who knows what Apache is? Who doesn't know what Apache is? All right, okay, a couple of people. So Apache is this software foundation out of California that kind of helps support open source projects. And there's kind of this famous thing called the ASL, which is the Apache Software License. The other big organization that supports open source software is the Free Software Foundation and their GPL, right? 2 different kinds of open source. So let's go ahead and start talking about big data and Hadoop. So first what I want to do is I want to talk about it at a very, very high level. Just kind of like what are we really talking about? And then we're going to go ahead and talk about the projects real briefly and Hadoop in general. And then we're going to go through some use cases that I personally have been involved in. Okay? So once again, any questions, anytime, shout it out. So big data. What is big data? Well, if you watch CBS News or CNN or anything, they'll tell you that big data is this thing that makes companies know everything about you. They know everything. They know exactly what you're going to do in the next 3 seconds of your life. And that's not necessarily true. It turns out that what big data is a lot of times it can help predict decisions that you would make simply because they have some information about you and they have a lot of observations or data points. So they can make very, very good predictions. But that doesn't mean they know, are all-knowing, they know something specifically about you. They can just make predictions about you, typically much better than before. So the reality of big data or Hadoop is really a couple different common scenarios. Typically, there's large volumes of data, right? That's why we call it big data. There's significant volumes of data. Now, how much varies? Some people, on a typical database system, storing 10 gigabytes of data on one database is troublesome. So at that point, you want 2 databases, you partition it, and you can partition it even larger and larger. But really, kind of like the entry-level size is like 10 gigs. If you have less than 10 gigs, super easy to process it on one machine. You don't need multiple machines. And Hadoop and big data are really about the size of volume, the volume of data where you need to have distributed systems to process the data. Okay? But it does go much larger. We have many customers at the company I work at, Cloudera, that have many petabytes of data. So that's 1,000 terabytes of data. But most people are in the 10 gig, 100 gig, 1 terabyte range. That's the vast majority of people. So the other thing, should the lights be off, or is this what we want? I mean, I'm fine with it. I just don't know if that's normal. Okay. All right. So the other scenario is data that doesn't fit well in a database. Let's just say we're going to create a website. What are we going to do? We're going to define our business objects, right? And then we're going to use some kind of technology to create our tables, right, in a database. And then we're going to do some work to get that data back and forth, okay? Now, the problem is that lots of data just doesn't fit well in a database. Could be size, but often it's on the kinds of data. So for example, there's lots of data in the web space where you don't have the typical mapping structure that you have in traditional data. So each record might have 100 fields. All of the records have 10 fields that are exactly the same. The other 90 fields vary heavily by record. Okay? That kind of data doesn't fit well in a database. Very hard to process in a database. So that's another scenario when these technologies are used. Another scenario is simply when people aren't making the best use of their data. So it used to be my first website was I sold counterfeit Mountain Dew t-shirts. I was too young to know they were counterfeit. I didn't know that I needed, a license to the logo, so I was just making it I was like 14 or something like that in my house. And, it was kind of involved in the web domain from that point forward. And a lot of data from websites just gets thrown on the floor and not even used. How users are using the website, what they did before they bought a product, common paths through the website. All of these things, a lot of that data is actually just being thrown on the floor. Well, it turns out that Google and Amazon and Facebook and all these guys, right, they figured out that, hey, there's actually a lot of value in that data. We can make good predictions on what people are going to do with that data. And it's not just website data. It's also sensor data from driving of cars, medical imaging data, lots of different projects going on. But people making better use of the data they already have. So, we've got to have one question. I know we haven't talked about much, but there's got to be something. Someone here is thinking something they would like to ask.
Give us an example of a company you've worked for.
Ooh. Yep. So, let me think about, I got to give a referenceable customer. That's one we can actually talk about. Most of our customers we can't talk about. Expedia is one customer that we can reference. So Expedia, based out of Chicago, travel website. They have lots of people doing searches and not purchasing things. So a lot of people look at, okay, they bought this, right? People are buying this hotel or whatever. But another interesting thing is when people do a search and they don't buy, why are they not buying? So those are the kinds of things that they look at as well. Orbitz is another customer that same domain. In terms of, it's probably easier to talk about who's using Hadoop because there's typically NDAs between us and our customers. All the websites, so everything, for example, every Facebook message you've ever sent stored in Hadoop. Almost every single cell phone maker the quality of service data being emanated back from your cell phone being stored in Hadoop. Okay? So they're using it to figure out why cell phones suck at certain points in time, right? Why are you getting bad reception? Genetics companies. So people are using Hadoop to process genetics data. So lots, I mean, it really spans the whole spectrum. So that's actually what I'm going to get into next. So let's talk about Hadoop, and at a very, very high level. This is an introduction. So really what Hadoop is a new way to manage data, okay? It's a comprehensive platform to manage data. So typically when you were doing anything with data, making a website, doing sensor data, anything like that, you had to build a lot of the tools yourself. You could get a database, right? But what if you wanted to get data from your website into your database? Well, that's pretty easy. That problem's been solved. But what if you want to run analytics on that data, right? Well, it turns out that your online website typically can't handle the volume of online transactions and what we call offline transactions or analytic queries at the same time. So then you got to have a data warehouse. Okay, well, that's a completely different technology stack. And you got to get the data back and forth, and so then there's more technology involved there. But these are all different products from different vendors. Hadoop is a common stack of tools that solve data management problems. Okay? Now, it doesn't solve every data management problem. You're not going to go out and replace your transactional database. You're not going to go out and replace your Oracle or MySQL database today with Hadoop. It started in more of the offline mode, so more of the process after the fact, and it's moving towards online. Okay? So it's an Apache Software Foundation project. It was started by a guy named Doug Cutting out in California. And he started a bunch of very, very commonly used Apache Software Foundation projects. Actually, he's the board of directors at Apache right now and works at Cloudera. He's actually going to be in town in May. So if you're interested in seeing him, he's going to be in town at a Cloudera event. Last slide has more information on that. Now, so this Hadoop project, it's not Cloudera's project, okay? Doug Cutting created it, he works at Cloudera, but it's not our project. We work with a whole bunch of companies on this. So we actually work, I communicate every day with our direct competitors' engineers. We work together to make the product better, okay? Obviously, we compete in a sales perspective, but I don't work in sales, right? So that's not my problem. I talk every single day with the engineers how to make this product better. Now, when I say it's a data management platform, there's something about that. So when people say Hadoop, generally, they're talking about this whole ecosystem of tools, okay? So tools that fit into each aspect of data management. But if you're talking in a very literal sense, Hadoop is just one project, okay? And basically what it does is store data and allow batch processing of that data. That's it, okay? There's a whole bunch of tools that we'll talk about very briefly, just kind of introduce you to them, and the functions specifically that they do, built up around the Hadoop project itself. And they're almost always at Apache. So why do we have this new data management architecture? So this is actually a clone of Google's internal infrastructure. So almost every single project in the Hadoop ecosystem has a counterpart at Google, okay? So basically what happened is, everyone, who's heard of Moore's Law, right? Everyone's heard of Moore's Law, right? Processors are getting faster and faster and faster, but we're actually kind of starting to plateau a little bit. And it turns out that, the different components of a computer change at different speeds. So while CPUs were getting faster, I/O, or reading data from disk, was getting faster as well, but at completely different rates, okay? So it turned out what Google hit in the 90s was a problem that is hitting most companies right now, larger companies right now. And very large companies they've been hitting it for a few years. And that is they simply have too much data for the data management architecture that was designed in the 70s, okay? So traditional data management architecture was designed decades ago. And it was designed, I'm not ripping it or anything like that, it was designed for the hardware they had at that point in time. But today, we actually operate on a little bit different playing field. The hardware has changed significantly. And some things have not kept up. For example, CPU speed has not kept up with data growth. I/O has not kept up with data growth. So we have more data, but the speed at which we read that data has not kept up, okay? So they hit this problem first because they were trying to index the entire web, okay? And so basically what they said is traditional data management's not going to work for this problem. We have to design our own systems. They designed something called Google File System. They designed something called MapReduce. And what we have here is clones of all of those different systems that they have inside Google. Google is very friendly to this ecosystem. They've actually approved us using, basically, they've approved us cloning their technologies. And the reason they did that is the problem that Google had was they would bring in someone, an engineer, and they'd have no idea how to use the technologies inside Google because it was completely different than everything outside Google. Now they can hire people that are much more familiar with the technologies they have inside Google because we have copies of them outside. Now, go ahead.
So this is not just like a one-time, here's what we were doing at this point in time, but they're continuing to give you guys more information about how they update their...
Yep, so the question is, and I'll repeat it for the video, the question is, it wasn't just a one-time thing. They're continually updating, saying, here's what we're doing. Are they doing that? That's the question. And yeah, so every couple of years, Doug Cutting likes to say, Google lives about 5 years in the future. And about once every couple of years, they put out a paper and they say, here's what we did a couple of years ago. And everyone's like, whoa, that's pretty cool. So then we start quickly creating a clone of that. Now, also, there's mixes back and forth. So like at Cloudera, we have a number of people from Google. And there's people that go to Google and there's people that leave Google, just general movement of people, and that information spreads as well through that mechanism. But yeah, I mean, it was really, so not all of these changes were designed by Google. Like, they kind of kicked it off, definitely. But there's been enhancements outside of Google on this architecture, okay? But yeah, basically, for the most part, if you look at a project, you can say, it's that project inside Google. It's that project inside Google, okay? So for example, there's a project called Apache Hive that does SQL. So SQL on top of this interface, or on top of this architecture. And the project at Google is called Tenzing, okay? And if you have, there's a project called Cloudera Impala, which is an open source, another SQL tool on top of this architecture. And its clone is Dremel, Google Dremel, okay? Any other questions? Yes?
So how is BigData different from data warehousing? Size and scale?
That's a great question. So how is big data different from data warehousing? And that's a great question. So like, it's not cut and clear, okay? The people that had the big problems, people that typically had the big problems with large volumes of data were data warehouses. So data warehousing technology been there out for a long time, but they found that they were throwing away data they wanted to keep because it was too expensive to keep it in the data warehouse. They were finding that, maybe they want to keep some data, or I'm sorry, maybe they are keeping data, but they don't query it that often, right? So we could move that to a less expensive store. And so they were really the people that kind of drove adoption of Hadoop at the beginning. Now, so if we just wanted to do data warehousing on top of Hadoop, we'd be pretty much done, okay? We have all the technologies that we need to do that. There's real-time SQL access, there's batch, there's tools to move data back and forth and stuff like that, and I'll get into that in a second. But it's also about machine learning, which you can do on top of data warehouses, but it's not exactly the ideal place to do it. And also dealing with data that doesn't fit in a traditional data warehouse. So, for example, log data, like from website, clickstream data, I should say, often doesn't fit that well in a data warehouse, but it fits very well in Hadoop. And if you have your data warehouse data also in Hadoop, you can negotiate those two types of data in the same job, same query. Any other questions?
If I want to run Hadoop, three options. One, I can set up my own cluster using open source software. Another one is I can go to Amazon's product and all the last MapReduce.
Yep.
The third option, I think are you going to compare and contrast those?
I can. I didn't plant him either. So the question is there's three. He sees it as three different options to running Hadoop, and one of them is using Apache Hadoop. The other one is using Amazon EC2. They have an elastic MapReduce program, and the other one is using Cloudera. So I would say there's just two options. Now there might be three. So there's really just two options. So, like for example, Cloudera Hadoop is really, you got Linux kernel, right? Who runs and compiles the Linux kernel and runs it on their laptop? Like 3-4 people, right? Everyone, if they're going to use Linux, they go get Red Hat, they go get SLES, they go get Ubuntu, right? That's exactly what Cloudera is for Hadoop. So I work on Apache projects all day long, and I also work on Cloudera's distribution, including Apache Hadoop, right? So what we do is they pay me to work on Apache Hadoop. It gets released at Apache. And we take those releases and we ship them, okay? But the problem is when you're working, like the Linux kernel, for example, right? When Linux puts out the Linux kernel, there's going to be some bugs there, right? So Red Hat doesn't just take the brand new Linux kernel and ship it off to their enterprise users, right? They test it. They deploy it to a certain set of quick-moving companies and see what problems they have, and then they fix the problems they have in the next version of the kernel, but they also fix it in the version they're going to distribute, right? So that's exactly what we do. So we take Apache projects and we say, all right, we're taking this version of it, and then we run a bunch of tests and things of that nature, and we push those changes back up to Apache and integrate it with all the other technologies and push those changes back up to Apache. And then we ship that product to our user. It's simply so that enterprises can have a dependable release cycle. Now, I think I got a little bit off track. So you're right. You can use Elastic MapReduce by Amazon. It's Apache Hadoop. They basically just took a copy of the code at a point in time and are running it and fixing it, kind of like we are. Nice thing about that is you don't have to set up your own hardware, right? The other option on top of Amazon is to take like our product or Apache raw product and install it on top of EC2. So that would be a little bit different, but still on top of Amazon. The other scenario is that you can basically buy servers and install our product on it, or you can go to Oracle and you can say, give me a Hadoop cluster that's already built. And there's other people that do it than Cloudera. We're not the only people. We were the first, but we're not the only people. It really depends on what you want to do. For example, when I'm writing code, when I'm developing, I use Amazon. It's very easy. I can just shut it down, I don't have to have servers up and running and things of that nature. But I will say that most of our customers, when they're running in production, are using their own hardware. That's just the way it is. Because there's a problem. You put 100 terabytes of data in Amazon, and then you say, we don't want to put it in Amazon anymore. It's going to take you 10 years to download that data. No. Right? Yes?
Can you give me an idea of how to store all this similar information, like genetic data, log images? I don't understand that.
The question is, how do you store all these different kinds of data? So you're storing images and genetic data and data warehouse data, all this kind of stuff, right? So Hadoop at its core, actually, I think that brings me right next to the next slide. My keyboard's not working again. All right. So we'll get to that in just 1 second. So there's a lot of different projects that are involved in the Hadoop ecosystem. Some of them are data storage. Some of them are languages to analyze data stored in Hadoop. Some of them are all about getting data in. Some of them are about coordinating jobs, so things that are actually running in the Hadoop ecosystem. So let's talk about that real quick. So data storage. Now, so Hadoop exposes a couple different interfaces. The most raw interface is just a file system, okay? So literally, you can take any file, image, clickstream data, data warehouse data, whatever it is, and put it in Hadoop. So it's like, however you were storing the data before, you can do that same thing on top of Hadoop. Only it's stored a little bit differently. It's in a distributed file system, as opposed to like a file system on one machine, okay? Now the other problem is, okay, great. So we got one directory, we got genetic data. The other one, we got radiology data. Like, how do we know what that is, right? How do we know the schema of that data? And there's a project called HCatalog that helps you essentially say, okay, here we've got this kind of data. Here we've got this kind of data. So it helps you manage the schema of what is in what directory, okay? Now, the other way to interact with data is essentially there's several NoSQL databases built on top of Hadoop. So there's one called Apache HBase, which is a clone of something at Google called BigTable. And there's another one called Apache Accumulo, which is a clone of the exact same thing at Google. So in the Hadoop ecosystem, we say, why make one thing when you can make two, right? So there's pretty much always two things to do the same thing. And usually one project ends up, at the end kind of winning. This is an interesting one. So Apache Accumulo actually came from the three-letter agencies, okay? So, from DC, basically. And was built with tax dollars. Now, you may say, why in the heck did they build Accumulo when there was HBase? Like, they're two competing projects. They do the same thing. Accumulo is a little bit better, a lot better on security, okay? Well, it turns out that when they were building Accumulo, and I say this because there was like a whistleblower in DC that said, the government wasted all this money building Accumulo when they could have just used HBase. Well, that's not true, because when they started building Accumulo, HBase was like, 50 lines of code, right? It wasn't a usable product. So, so these are essentially NoSQL data stores. If you want to talk about it, you want to look it up on the internet, or you want to talk about it afterwards, I can get into more of the details, but it competes with the likes of things like Cassandra, MongoDB, things of that nature. So there's batch processing built on top of Hadoop. So you can write code in just about any language you want and run programs to query, to analyze, to manipulate that data you have stored in Hadoop. So there's a blog post out there that has like an exhaustive list of every possible way you can run a MapReduce program. So this is batch processing. We're going to run a query, comes back in an hour, comes back in 10 minutes, comes back tomorrow, right? A lot of times the data warehouse folks were the first people to jump on the Hadoop bandwagon because they had queries running their data warehouse that would take 3 days and then fail, right? And then what do? You're like, shoot. So a lot of those guys, they jumped on the Hadoop bandwagon. They're able to take those 3-day queries and run them on top of Hadoop, have them succeed. They'd only take maybe 8-9 hours, right? And furthermore, that freed up a lot of resources in their data warehouse to do the things that data warehouses are really good at, okay? So it didn't eliminate their data warehouse, but it allowed it to essentially use that resource much better in a more efficient manner. So real-time processing. So this is processing data, soon after it's generated, seconds or milliseconds after it's generated. There's a SQL-like language to do that called Cloudera Impala. This is an open source project. The way Cloudera open sources software is that we build it, we put it on GitHub, and then eventually we move it to Apache, okay? So we like to build up a community of users and developers before we move it to Apache. So that's why it's Cloudera Impala, not Apache Impala. Data ingestion. So there's a tool called Apache Scoop that we created, moved it to Apache, and it allows you to interact with a relational database. So take data from your data warehouse, move it into Hadoop, take data from your Hadoop, and move it into your data warehouse, okay? There's a tool called Flume that I actually work on quite a bit. And this is for taking real-time data and putting it into Hadoop. So Scoop is for like every hour or once a day, you run a job to import some data into Hadoop. Whereas Flume is, we have a transaction on our point of sale device in our store, and we want it in Hadoop to be analyzed 1 second later, okay, that kind of thing. 2 different tools for 2 different problems. And then there's a bunch of tooling for ingesting files, just whatever, your data probably exists as files. There's tools for ingesting files, including my very own HDFS NFS proxy. That's my project, so I'm kind of proud of that. And all these projects are, of course, open source Apache licensed. So here's an example of how this might be deployed at a retail location. So this is a dual channel vendor. They have a website, they have a store, right? So they got point of sale devices and they got their website. Hadoop's not going to replace the infrastructure that's running the website. Hadoop's not going to be there. Hadoop's going to be on the back end dealing with data management issues, okay? So you're still going to have your .NET website or Ruby or whatever it is, and then you're going to have whatever technology is doing your point of sale stuff. Then you can use Flume to ingest that data. So moments after there's a transaction, it's going to be inside of HDFS, ready to be queried by Impala, because Impala, you can submit a query, get the results back in a few seconds or sub-second. So as soon as that transaction is done, it's available to be queried by analysts. Maybe you have some of those queries that used to run in the data warehouse that took 3 days. To do that, you're going to use Apache Hive, which is built on top of Apache MapReduce. So Cloudera and Hive are the same language, just for different types of queries. Okay? So the same exact language, it's SQL-like, it's pretty close to being SQL, but there's a few differences. And of course, maybe you want to import and export data from your data warehouse, you're going to use Scoop to do that. Any questions about this? So this is not meant to be an exhaustive how to implement a Hadoop cluster in a retail business. Just to kind of give you an idea of how the different pieces plug in. But any questions whatsoever? Shoot them out. Yes?
I'm sure I fell behind. HDFS, I can picture that. What is MapReduce?
Okay, excellent question. So the question is, what is MapReduce? So MapReduce is a way to process data in batch, okay? And so essentially, whenever we're doing batch queries, we've got to have a strategy to do the query, right? And MapReduce is essentially an architecture for processing data in batch. And so the most raw way that you can interact with MapReduce is you can write a Java program that literally has a mapper and it has a reducer, and you submit that to the cluster, and it runs a batch job, outputs data to some location that you've specified. Okay? Or what you can do is you can run a Hive query, and Hive actually generates a MapReduce job for you, maybe 3 jobs actually, and runs those in series, and then gives you the results. Okay? Or you can use Ruby or Python or Perl or whatever you want to do to write a MapReduce job. Okay? So it's really a way to process data in batch. And it, of course, is cloned from Google. They're the ones that came up for it. Actually, Jeff Dean at Google was involved with it. And Jeff Dean is Jeff@Google.com. He's famous at Google, or famous everywhere, I guess, these days. And he actually went to the University of Minnesota. Briefly, I believe. He wasn't here for 4 years, I don't think. But he was here. So that's a great question. So Impala is not doing MapReduce. So MapReduce is a batch processing system, whereas Impala is about doing real-time queries. So MapReduce is probably never going to give you a sub-second response. Just never going to happen. It's not architected that way. It's architected for doing big, voluminous queries. Whereas Impala is actually a clone of something called Google Dremel, right? And so it's essentially what we call an MPP database, which is a way to execute a query on very large amounts of data. But if something goes wrong, the query fails, you got to rerun it. Whereas MapReduce is very good at handling failures and things of that nature. Okay?
Apollo give you imperfect results? Does it like trade off, like maybe not all the nodes respond or something for a quick and dirty response versus a more accurate one with MapReduce?
So that's a great question. So the question is, could Impala give you imperfect results? Is it trading off, like maybe some of the nodes don't respond, so it's going to give you partial results in order to give you quick? And the answer is that's actually a feature, but it's not implemented in Impala. So what you can say there's actually a couple clones of Dremel. Facebook has a clone of Dremel, and internally, and they have a feature where you can say, I don't care if I get all the data. You can actually sit there and you can say, okay, I feel like I've got enough data. You hit the right key, and you get your results back. But that feature is not implemented in Impala. Basically, if the data is actually on 3 different nodes, if all 3 of those nodes are inaccessible, it'll give you an error back. Yes?
Have you seen any implementation of Hadoop where it's being updated very frequently? Like I can think of example of Google Analytics real time.
Yep.
Is it an appropriate solution for that kind of need? Not exactly analytics, but
So the question is there any so from like an implementation perspective, there's only one Hadoop, right? There's only one implementation of Hadoop. And in terms of like maybe implementation means like a specific use case, right? And yeah, there's lots of use cases that can be done in real time. Typically, you're using HBase to store the data as opposed to HDFS because that's more of a real-time data store. But we'll go down here and then we're going to move on because we're running out of time. Yes.
I was just curious, is the website interacting directly with the Hadoop environment to pull data out and serve data back to the website in this example, or is there still like a relational database that is sort of assumed in that website block?
So that's a great question. So the question is the website hitting HDFS directly to serve up data? And generally, no. What you have is you put the data in Hadoop, you run and generate some models of your user, and then you use those models to make some predictions about what product they would like or respond to search results and things of that nature. So you basically generate the model in offline and then push that model up to your website, and then it uses that updated model. Now the thing is, people have been doing that for a while, but typically they would update their models like once a week, or like extreme guys would do it once a day. Well, with Hadoop, you can do it like once an hour. Like that's the way people are doing it. And Google actually, there's a company that built an infrastructure similar to Google. Google now does it. If you make a purchase, your model will be updated instantly. Okay, so that's where everyone's going, but the rest of us are not quite here, not quite there yet. All right, so let's just move on. So I'm going to talk about 3 use cases, and then we'll be done. So I'm just going to kind of talk through what the challenge was, like why did we use Hadoop, what the requirements were, and what the solution was, which technologies they used. So these are all projects that I've worked on personally. So large website. So this was a large website. They had large amounts of user data. They had preferences of users, things they had purchased, and things of that nature. The problem is very often happens, is they had this data in like 5, 10 different systems. Okay, so this particular feature needed this particular data management tool, this type of database, whatever. So that kind of data is siloed over there. User data is siloed over here. Purchases, history of purchases is over here. Very, very, very common problem. And essentially what they wanted to do was perform analytics on this data, but in order to do that, you got to get it in one place. So what they wanted to do was basically create a platform where they had all data forever. Like they were never going to delete anything. And so they used Hadoop. Basically, all of those data sources in an initial revision pushed their data at whatever interval was appropriate for that type of system to Hadoop. And Hadoop was essentially the system of record going forward, okay? So they also wanted to replicate this data geographically. So they wanted to have it in California and on the East Coast. So the solution we had was HBase. Our solution we used was HBase. So this is a NoSQL database. And it supports not only replication within a data center to make sure your data is available, it also supports replication across geographic locations. So very, very common. Most, or I wouldn't say most, a lot of large websites are using HBase to do this exact kind of thing, to basically store all of their user information. Now, the reason that they chose HBase was that it plugs into this ecosystem, so they got MapReduce for free. They got Impala for free. If they chose something else, then they would have to build some kind of integration to make it work with MapReduce or to make it work with Impala or to make it work with any of these other tools. HBase is part of the ecosystem. Integration's already built with all those tools. So now we have a global bank. So this is a project that I worked on. And basically what they had, very, very, very large global bank. And every night they need to know, what do our books look like? How much cash, are we solvent, right? Do we have enough cash to satisfy our demands, to satisfy the government's requirements? So they have this enormous financial reporting infrastructure. All the different lines of business report up every single night saying, here's what we've done during the day, and that's how it affects the business's balance sheet, or the bank's balance sheet. The problem is, every bank, oh, I'm going to buy this business, I'm going to buy that business, I'm going to buy that business, I'm going to buy that business. And so they had literally thousands of different formats of data coming back. So what they needed to do was take that data, transform it to a single format that could be processed in their data warehouse, okay? So the problem that they had before was because of the volume of data, they couldn't, these transformations take several steps. They may take 4 or 5 steps to get them in the final data, the final resulting data. The problem is, what if something goes wrong in the middle, okay? You get some bad data at the end, something went wrong in the middle, but you don't know where it happened, okay? So it's very hard for analysts to track this down. You had a lot of extra analysts that you didn't need. So with Hadoop, basically, what they were able to do was store the values, or the intermediate transformations, and then very, very quickly look up, say, okay, I got a bad value. Let's look up each step of the transformation, what this data looked like, and we can find out where that bad value was generated, okay? Save them a tremendous amount of data, or a tremendous amount of resources. I mean, and it's good for the analysts, to be honest with you. I mean, these people were just looking at, we got a bad value, now I got to figure out where it came from. Now they're doing things that are more interesting. So they also wanted to keep all intermediate representations for 7 years. Hundreds of terabytes of data. Guess what? Hadoop is good at that. So they used HBase with compression, was able to handle that. They used MapReduce to process the data, to run their transformations. And it was a very, very successful project. So, retail. Now, this retailer, large retailer, been around for a long time. Every group had their own data warehouse, literally. There's 35 different data warehouses. Different vendors, every vendor under the sun, okay? Because this business made their decision and this business made their decision. So what they wanted was basically to take all of that data, put it in a single system so that they could analyze it together, provide it to their vendors so they could see how they're selling more efficiently. Their goal was to offer real-time offers on Black Friday, okay? So they had a real-time requirement. So they chose Cloudera Impala over initially 250 nodes. It's actually, I probably should update that. It's much, much bigger now. So it's a real-time, they had a real-time problem. They used Impala. They also used MapReduce. So sometimes they want to run a query. It's going to run for a few days. We just want to let it run. So they use MapReduce for that. So that's kind of the difference there. Questions? I think we have just a couple minutes left. Yes? Yep. So
Where does the agnostic come in from a hardware, from a database, OS, and then it becomes
So the question is, he asked if it was a standard and when does it kind of get agnostic to the different vendors. So Hadoop is not a standard. It's a single implementation, okay? Now this implementation is open source. Anyone can download it and use it for free. In fact, they can download our essentially version, which we call Enterprise Hadoop, and use that for free as well. Now, the key thing that this is built is written from the ground up to work on commodity hardware that you can buy from any vendor. I shouldn't say that. Our partners would like us to call it standard hardware. He works for Cloudera too. Standard hardware, not commodity hardware. So essentially, you can buy standard hardware from any vendor, and it doesn't need those bells and whistles of HA or anything like that. It's built in itself. Yes.
Quick question for you. So does Cloudera or any of the Hadoop Apache projects that you're aware of offer a business intelligence package to go on top, kind of all in a TISA?
So there's no Apache projects that do BI. There's a few. There's like something called like OpenBI. There's a couple projects out there that are around or whatever. But generally at this point, the BI stuff is done by the different vendors. So Tableau, MicroStrategy, but all of those things plug into Hadoop. Pentaho is open source. Yes.
And one other question.
Yep.
So have you found any advantage with specific hardware? So, I mean, like when you're building out, like a rack or a cluster, right?
Yep.
You're finding that certain processor types are working better than others, or is it just pretty much straight kind of normal commodity hardware?
So the question is, what types of hardware work best for Hadoop? So generally, you're talking, standard hardware. We actually have a good blog article on Cloudera's blog. If you shoot me an email, I can shoot it to you, where we basically describe what kinds of hardware that should be used. But generally, it's like you don't go for the fastest CPU. You go for a little bit lower than that. You typically are going to have 48 gigs of RAM and 12 disk drives per machine. Yes?
So like all the tools are freely available, but the data, it's like if you really want to play with big data, are there like public instances that you can play with?
So the question is, are there public instances of data? Yes, Amazon has public data sets freely available that you can download. There's also called data.gov where you can download fairly large data sets. Or you can download a VM from Cloudera. So email me if you have any questions. If you want to come see Doug Cutting, there's the information for that. If you're interested, join the Hadoop user group. There's also a group called MinneAnalytics. So if you go to minneanalytics.org, they're much more, so the Hadoop user group is very Hadoop focused. They're definitely analytics focused. Do you want to talk about that quick, Dan?
Yeah, MinneAnalytics is like MinneBar. We had a conference in January, about 600 people showed up. It's free. And it's about using Hadoop feeds the data that the analytics people use. About data, tech, business, and data.
Okay. Thank you very much.